recording now. So here we have a question. We're given different colors here, and we have the frequency, the number of times they occur here. We have the total here. You see that 1720 is the total, so you don't have to bother adding them since you're given the total. So find the probability that you will get an orange. So this is pretty straightforward. Orange will be 394 over 1720. Now they want the answer as a fraction, so you put it as a fraction here. So you go down here, you click this guy here, then you put your 394 over there, and then you put a total here, 1720. And then of course they want it as a decimal rounded to three decimal places, and you know what to do. There's even a video here for that very easy question. Let's move on. Okay, so this one is a multiple choice question, so we will not do it. Oh, you have three options. You have three tries. You can get it wrong. Okay, assignment one is due October 10th. Yes. Okay, so a bag of M&Ms has 5 red, 6 green, 8 blue, 2 yellow. We've seen something like this before, right? So uh, do not message instructor on this question. Okay, so again, you add up all the M&Ms and divide by the number. But this one says blue or green. So blue or green just means either blue or green. So basically, you're taking all the blue and adding them all with all the green. So that would be 6 plus 8 here. So that would be 14. And then I think the total you have here is 21. So it will be 14 over 21. Okay, and make sure you round your answer correctly to the required number of decimal places. Okay. Now, if you need me to pay attention to any of these questions, let me know, because I'm assuming you can figure these things out. That's why I'm moving fast. This one even has 2 videos. So this one again is straightforward. So I'm going to move on. Okay, so these are all pretty easy one. The answer has a percent this time, so watch out for that. Okay, so this is similar to the question we saw. Again, there's a video here. You can choose 2 appetizers, 5 entrees, 5 desserts. How many 3-course meals can you order? 2 times 5 times 5. That is also very straightforward. So again, 6 colors to work with. You want to design a flag with 5 vertical stripes of all different colors. So you know what to do there. Okay, so for this one, they just want you to punch this in the calculator or use Excel. So again, we just saw that. You use Excel or use calculator for that. For this one, a pianist plans to play 5 pieces of a recital. In how many different ways can she arrange? Remember the factorial thing? You just want to arrange them. She's not selecting, right? So just 5 factorial, 120. Okay, aha. So here, I have a question for you. So you can type your answer in the chat box. In how many ways can the first, second, and third prizes be awarded in a contest with 605 contestants? So first, let me ask you, is this permutation or combination? Can you type P or C in the chat box if it is permutation or combination? So we got a combination, we got another combination. Okay, can we get 2 more? And then I'll explain. Okay, Nicole changed her mind, and then we have Marianne. Okay, good. So good. So yeah, good change of mind. Permutation. Why? Because order matters. Remember, order matters. So the 3 people selected, if they're, so let's assume this is the first position. there's the second position, there's the third position. So if you select 3 people, you can still rearrange them here between these positions. Okay, they could still get different prices, right? And so on. Okay, so they could still get different prices. So order matters, so it would be permutation. So the question is just asking you to do 605 permutation 3, like that. So again, I'll just show that in Excel. And again, you can use a calculator. So it's just going to be equals permute, okay, 605, 3. Okay, oops, it's a huge number. I'm going to copy that and paste. So that's one thing Excel does for you. If you do this manually, you have to now, punch these numbers in one by one, and you can even make a mistake doing that. Okay, find the number of distinguishable permutations. No, by permutations here, they mean arrangements, okay, of this letter. So remember when we talk about when we're doing arrangements with repetitions, so first going to count how many do we have here? 9. So we can arrange this in 9 factorial ways, okay? 9 factorial ways, but we have repetitions. We have A repeating 3 times, B repeating 3 times, C repeating 3 times, okay? And that gives us the answer to that one. How many 2-letter words can be made from math? 1, if repetition is allowed, repetition is not allowed. Okay? So if repetition is allowed, right? Remember, you want to pick 2 letters, right? So you pick one. You have 4 ways of picking a letter. But if repetition is allowed, it's like you've thrown that letter back into the box. You can reuse it. So you have 4 ways again. So it's 4 times 4 for part A. But for part B, repetition is not allowed. You want to pick 2 letters. So you have 4 ways of picking this one. But once you've used that letter, you can't reuse it anymore. So you have 3 ways left. So that's the difference between the two. And you have 2 videos for that. Okay. Over here, you want password, right? It's 5 characters long. How many are possible? Okay. Now, you require 1 letter followed by 4 digits, okay, where no repetition is allowed. Okay, so let's see how this one plays out. No repetition is allowed. Okay, so they are 5 character long, so you set up something like that, okay, for the 5 positions, and then you're gonna go like, okay, if the password required 1 letter. Okay, so for international students, you have to note that there are 26 letters in the English alphabet. Uh, okay, so we have to remember that. So you have 26 ways of filling this spot. Okay, and once you fill that spot, the other 4 have to be digits, numbers between 0 and 9, and you cannot repeat them. Okay, so then you have 10 ways of filling the spot then. 0 to 9 are 10 digits. And then 9 ways of filling this because you cannot repeat, 8 and then 7. So you multiply those and that will be your results for the number of possible passwords. Okay, how many different recital programs are possible? So here, you want to play 4 pieces from 18 pieces. Okay, now you're also considering the which one to play first, second, and so on, which means order matters. Okay, so if you're just looking for a bunch of 4 songs, right? So let's assume you're going to the gym and or you want to work out and you have 4 songs you want to listen to, and you think, you know, I have to listen to this first, then that one, then order matters. Now, if you just want a bunch of 4 songs and you don't care about which one you listen to first, second, or third, It does not matter, but in this case, order matters. So you guys know you have to use permutation when order matters. Okay, tubular, 18p4. Thank you. That's the answer to that last one. Okay, so what about this one? Can someone type the answer to this one uh, in the chat box? Tubular. How many different permutations, that is different arrangements, can you have for the letters of the word tubular? 1, 2, 3, 4, 5, 6, 7. 7 letters. What is the answer to this question? We have 7 letters and we want to arrange them. Okay, we're not selecting out of them. So we have 7 factorial, and then we have to see which one repeats. Only U repeats here, so done. We're going to divide by 2 factorial, and that answer there is 2520. Okay, that's what it is. Okay, thank you. So that is how we do that. 5040 divided by 2. Yeah, that's correct. Okay, another one here. 8 sprinters have made it to Olympic finals. In how many different ways can they win gold, silver, and bronze medal? Anybody want to type that? 8 sprinters made it to the final. In how many different ways can they win? So basically, you want to select 3 people from these 8 people, and they're going to win gold, silver, and bronze. Thank you. 8p3 because order matters. Thank you. Last question for today. Oops, this one is long. Okay, so the good thing about this question is um, it has a type solution for you to look at. So what some people actually do is they take the question and just submit it for the first attempt, since you guys have 5 attempts, right? So they submit it for the first attempt, and then they'll go back and look at all the answers, and then they now use that to answer all the questions. I think it's a smart move. Okay. You have a group of 11 students, right? So you have 11 students in total. You have 6 females and 5 males. So you want to select 4 people. How many different 4-member committees are possible if there are no restrictions? So this is a committee, right? Which means order does not matter. We just want a bunch of 4 people. So you just need, so for the first question, part A, it's just going to be 11. You want to choose 4. That's it. Okay? Just a committee of people. Now, how many 4 different committees are possible if there must be exactly 2 girls? Okay, there must be exactly 2 girls, and you're choosing 4 people. It means there have to be 2 boys as well, right? So it has to be, out of these six people, we want 2, and out of these 5 people, we have to choose the remaining 2. But guess what? We have to do this, we have to do that, and the fundamental counting rule says we have to multiply these 2 results to get the answer we need. Okay, part C. Now, part C is a little tricky. How many 4 different member committees are possible if there must be at least 1 girl? Okay, so it's a concept we're supposed to be touching on next class. But the way to look at it is, if you want to do it the long way, right? You're going to say at least 1 girl means it's either that we have 1 girl. Okay, good try, Derek. Um, so there are different ways of looking at it. Okay, at least 1. Okay, we haven't covered at least 1. It's a little bit tricky. The at least 1 part is a little bit tricky. So, when they say at least 1 girl, right, it does not mean 1 girl. Okay, it means at least 1 means it could be 1 girl, it could be 2 girls, it could be 3 girls, it could be 4 girls. Okay, that's what at least one means. So if you want to do it the way you guys are trying to do it, then you have to say, okay, it's either going to be 6C1 times 5C3. That is one girl and three boys. And then you go, or means we add, which is something we're supposed to cover next class as well. 6 combination 2, so that would be two girls and two boys. Or 6 combination 3, which would be too long. Okay, so it'll be too long to do all this. Okay, good. So the way to think about it is, in how many ways can we select no girl at all? Okay, so how many of the selections will involve no girl at all? Okay, which means 6 here we will choose 0 times 5 we will choose all boys. Okay, so the opposite of that is, it means we have at least one girl. So we're going to take the total number of selection here and subtract this result that I just calculated. So this result means no girl, all boys. That's what it means. So when we subtract that, it means the remainder will have at least one girl in it. So we're going to do 11 combination 4 minus this result, and then it will give us at least one girl. Okay, so it's a little bit tricky. If nobody showed it to me, I won't know it either. And then last one is asking us, find the probability that you will get at least one female. Oh. So basically, you're supposed to just take your answer here, right, and divide it by 11 combination 4. Okay, so but this question has a written out solution. So if you want to see it, you can just donate your first attempt, submit an end, and then you'll be able to see all the answers, and then you can now use it to answer your question. But I think this question is the most challenging one. Everything else seems to be straightforward. So that's it, guys.